All right, so in this particular problem, you again have a couple choices. Since most students prefer to treat everything as individual fractions, you can do it that way. The simplest way would be to do what? Does anybody see what would probably work the fastest here? That method 2, the LCD method. If I were to multiply, if I took this whole thing as an entire fraction and I multiplied the top and bottom by the LCD of every fraction involved, I need a 1, an x, and x squared, a 1, an x, and an x squared. So what's my LCD going to be? No, so remember, you don't need to add them all together. You just need the fewest number that accounts for any one fraction. So x squared has this single x embedded within it. So here's my LCD. So if you can recognize that that method works, you can distribute x squared times each of these terms. That gives you 3x squared minus here 1x cancel, so we're left with 11x. Here both the x's cancel, leaves plus 6. And then when we do the same thing in the denominator here, distribute the x squared. Here we get a 3x squared plus 4, one of the x's cancels, and then minus 4. And so if we're looking at this, it just becomes now a problem that you look to find binomial factors. Okay, so I know my 3x and x are my first terms. My second terms have to give me a total product of plus 6 and a sum of a negative 11, so I know these have to be negatives. And because of this 3 here, I know that this number, it can be a 1 and a 6, but it can't be a 6 and a 1, so I don't even need to test that. So let me test a 1 and a 6 here. I get negative 18 minus 1 does not work. Okay, so I can go back, test a different set. A 2 and a 3. I can't be a 3 and a 2 because a 3x minus 3 would have another factor out of it. So let me try to FOIL this. I get minus 9x minus 2x. Does that give me negative 11x? Yeah, so here's my factors. In my denominator, I can do the same thing. Look for binomial factors, 3x and x. Okay, now I'm going to test negative 2 just to see. It's likely that that would be the case here because these factors may cancel. So if I take the two factors of negative 4 are negative 2 and a positive 2. So if I FOIL these, check my outer and inner products, I get 6x minus 2x does equal plus 4x. So this is my factored form. The common factors cancel, and I'm left with x minus 3 over x plus 2. If I go back and look at any domain restrictions, I see right here that x can't be 2/3. Okay, that restriction's not shown in my simplified form. Okay, but then I have to go back into the original form as well. So in the original form, I see right here that x can't be a 0, and that's true here as well, and then each of these up there. So I have the additional domain restrictions that x can't be 0, and it can't be 2/3.